Hi everyone, in this video we're going to go through the solutions for VCAA quiz number 11. So after this quiz, if you've done all the other quizzes, you would have done 55 multiple choice questions, which is pretty awesome. And so remember, you can make a lot of progress just bit by bit at a time. So don't wait until the exam period to start revising for your exams. Okay, so this quiz is just focusing on continuous random variables. So if you haven't started chapter 15, you probably struggle with this quiz. So I would encourage you to finish 15A and B and then maybe do this quiz. Okay, so for question 1, we've got a probability density function f is given by. Okay, so we've got our function here. Whoops. Why do I press highlighter and then it doesn't come up? Highlighter. Yeah, and we're going from 0 to 2, and we have to find the median. Now, the thing is, it hasn't told us what m is, okay? So we actually have to, instead of just finding m, we have to think, well, what are we actually doing here? So we are finding the antiderivative going from 0 to m, 1 on 12, 8x minus x cubed dx, and because it's the median, we're going to let it equal 0.5. Now if I put all that into my calculator, it's going to give me the value of m, which I've actually just done, but which you didn't see because I did it before the video, and I actually get a few values of m, which doesn't help us with this unless we're going to check each one individually. So what I'm going to do is not that, just highlight the antiderivative and press enter. And we get negative m4 on 48. So I'm going to write that down, negative m to the power of 4 on 48. And what was the other term? Plus m squared on 3 is equal to 0.5. So at this point you can see none of these options are similar to this. So we've got to get it into this form. Okay, so you can do maybe process of elimination. You can see we've got m to the power of 4 and m to the power of 2, which is all of those options, so that doesn't really help us. So let's, but none of them are written as a fraction, so let's get rid of these denominators. All right, so let's make them both 48. So 3 times 16. Let's go to do a different color. All right, it's going to make that 48. So whatever you do to the bottom, you've got to do to the top. And then I've got negative m to the power of 4 over 48 plus 16m squared over 48. And let's change that 0.5 into a half. Okay, we can always change it back if we need to. All right, so let's tidy things up a little bit. So I'm going to multiply everything by 48 just to get rid of those denominators. So this whole side is going to be multiplied by 48, and this side is going to be multiplied by 48 as well. So that 48 cancels out with that 48, so I'm left with negative m to the power of 4. And it also cancels out with that 48, so plus 16m squared is equal to 48 divided by 2, which is 24. All right, at this point I can see it doesn't relate to any of them, but I can do a process of elimination. It's not going to be that one, or that one. So at this point in time it's D or E. Now I can clearly see it's E, but let's just rearrange it to get into that form. So I'm going to make that anything that on the left-hand side that is positive, I'm going to make actually, let's bring that negative 24 over first. Sorry, there's always multiple ways you can do things. All right, and now anything that is negative becomes positive and anything positive becomes negative. So there you can see how you get option E as your correct answer. All right, moving on to question 2. A probability density function is given by, so here we've got a cos function and x is between k and k plus 1. And we know that k is some value between 0 and 2. All right, so we've got to find the value of k. All right, because it is a probability density, sorry, I wanted the highlighter. Probability density function, we can let it equal 1. So we're going to go find the antiderivative from k to k plus 1 of cos x plus 1 dx equals 1. So let's see what we get when we put that onto the calculator. So I actually haven't done any of these questions yet, which is a bit silly, but let's just see how we go. K plus 1, and then we've got trig cos x plus 1. Come on. Dx. All right. So we've got sine k plus 1 minus sine k plus 1. Now I just realized that I didn't let that equal 1. So let's go back and do solve. Silly me. Solve. And I've already worked out what that equals, so I can just highlight that. Scroll down. That is equal to 1. So remember, it's our probability density function. So I didn't put this. Sorry, go to highlight it. Okay, so I didn't do solve for equal to 1. So that's why I'm doing this again. That's not what I wanted. All right, so equals 1. And then we're solving for k. So comma k. Let's close our brackets. All right, so we've got k as a, what do you call it? General solution. Okay, so what we've got here is a constant. So it's pi times constant minus pi on 2 minus a half. So what we can go and do is highlight this again, which I should have done before, and just restrict that domain. And hopefully that'll work for us. All right, given, and k is between 0 and 2. All right, so there you can see k is equal to pi on 2 minus a half. K equals pi on 2 minus a half. Now it's none of those solutions there. It doesn't look like that, but we've got the same denominator. So this is where you really need to be able to rearrange. So pi minus 1 on 2 gives us the answer of D. So probably a bit quicker than what I did on the calculator, but not a difficult question. All right, but just to take me a while. All right, question 3. The continuous random variable x has a probability density function given by the value of a such that the probability of x is less than a equals this is. Okay, so here's our function. And here is our restriction on x, but we want to know x is less than a. So let's set up our definite integral. So because we want x is less than a is going to be our upper limit and our lower limit is 3 pi. Okay, so x is between 3 pi and 5 pi, so 3 pi is our lower limit. Then we're going to put in our function, so x on 2 dx, and that is equal to root 3 plus 2 on 4. Now let's see how we go with the calculator. Okay, where are we? Just find the right button. Okay, so 3 pi. And we can put, can't put x, but put y if you didn't want to scroll to the what do you call it, alphabet screen. 1/4 cos x on 2 and we've got dx, and I didn't do solve, so let's go back and do solve. Silly me. So solve, and it is a cos function, so we're going to have to make sure we restrict that domain as well. So that is equal to root 3, it's taking forever, plus 2 on 4. And then we're solving for a, and then we're just going to restrict x, although I'm not sure what it's going to give us if we're just going to restrict x. 3 pi, actually the value of a, given that a is also between 3 pi and 5 pi, so let's just do that. What am I doing? 3 pi. Takes forever to type on here. All right, so a is 14 pi on 3. And then you can see answer B. So not a hard one to do on the calculator. It just takes me a bit of time to type. All right, question 14 is a bit of an interesting one. So the graph of the probability density function of a continuous random variable x is shown below. So if x is greater than 2, then the expected value is equal to. Now, when we're doing the expected value of continuous random variables, it's equal to the definite integral of x times f of x dx, whatever your limits are. So let's just go from negative infinity to infinity. In this case, it's between 2 and a. So we're going from 2 to a, x times, now f of x is this line here. So it hasn't been given to you, but it is a horizontal line going through 1 over 6. So that equation is y equals 1 over 6. So your function is just 1 over 6. All right, and we want the expected value, so we can just go ahead and do that on the calculator. Actually, I'm going to solve for a. That is, hold on. I think I've gone ahead just a little bit too quickly. Let me just think. Okay, so I actually think I did the next step. What I need to do is find a first. So we're going from 2 to a, and we're not doing the expected value yet. So that's going to come later. I'll just write that there so we don't get mixed up. So your expected value, we've already done the function, so 1 on 6 dx. So we're just going to find out what a is equal to first. Oh, and because it's a probability density function, we're letting that equal 1. So on the calculator, let's go do solve first. Solve, and then the definite integral, we're going from 2 to a. And the function is 1 on 6 dx equals 1, comma, a, close your brackets. So a is equal to 8. Now we can go on and do the expected value. All right, so we know a is 8, so we're going from 2 to 8, x times 1 on 6, x on 6 dx. All right, so let's now do that. You can just highlight that. It's not much to write though. So a is now 8, and we just got to put the 1 up the top there. Not 1, sorry, x up the top. All right, so it's equal to 5, which is B. Now there is another way you can do this because it is a rectangle. So your area we know is 1. All right, so you can find out A that way. Not sure whether I should explain that way or not because I'm thinking on my feet. So here's our rectangle. Actually, we'll do it. So there's your rectangle. Great colouring in skills. All right, so the area of a rectangle, so where can we do that? Just do it down here. Area is equal to, so the height is 1/6, and, well, length times a minus 2. And that is equal to 1. So that's another way that you can get your value of a, because that is a rectangle. This distance between 2 to a is just a minus 2. So we're going to have, what's that going to be? A/6 minus 2, so 1/3 is equal to 1. Let's just keep going. So that's going to be 1/3, 4/3. So 6 times 4 is 24 on 3, so a is equal to 8. All right, so that's another way that you could get 8. And then your expected value, because it's symmetrical, is just halfway. So the halfway point between 2 and 8. So we just add them together. Might just do over here. So your mean is equal to 2 plus 8 divided by 2. And you could also get 5 that way. So we did it, we're learning how to do it using the definite integral. All right, so the way that we would usually do it, but because of the shape of this area, which is a rectangle, you can easily do it the second way. All right, let's move on to question 5. So for the continuous random variable x with the probability density function, all right, so let's just highlight a few things just because we can. All right, so there's our function. We're going from 1 to e, and we've got to find the expected value. So as I said before, your expected value is just x times your function. So we're going to have x log ex, and we're going from 1 to e. And don't forget to put the dx on the end. All right, so let's just put that straight into the calculator. 1 to e. Now you can just write e to the power of 1. X times, now it's a natural log of x. Well, let's be consistent with our x's. Dx. All right, so the answer is actually in decimal form, so let's just change that to decimal. So 2.097. So the answer is E. And big smile, that's hard stuff, girls. All right, and a little wave. All right, have a great day.